Welcome back. This is section 7.3, Identifying Action and Reaction. In your textbook, this is section 6.3. So what we've spoken of in the past is that one hand cannot clap by itself. A clap only happens as an interaction of two forces, the right hand hitting the left hand and the left hand hitting the right hand, and that's where you hear the noise. It's the same thing with any force. You're going to have, for every action, no matter what that action is, if you're exerting a force on something, you're going to get an equal and opposite force back. So all forces act in pairs. So many times this is hard. This is identifying what is reacting with what is sometimes difficult. So we've seen, all right, let me give you an example that I've used in the past. A car will push, the tires will push by friction on the road, and the road will shove on the tire, and that shove on the tire propels the car forward. If you're in the mud and it's very, very low friction, or you're on water and you hydroplane, the tire is not gripping the road and you don't go forward. All you are is just falling. You're flying through the air. You're essentially going at constant speed, with no real ability to control your direction. You're just moving at whatever the last force was at that direction. It would be almost like throwing a ball and then the ball being free from your hand, and the hand is no longer controlling the direction of the ball. If you go around a curve, when you learn to drive, you'll certainly know this. If you go around the curve, you have to slow down going into a curve, because there's an acceleration. We'll talk about that later. There's an acceleration in that curve. And if there was ice, say, on the curve, your car is going to hit that ice and go out of the curve and off the road. So if your car ever has gone around a turn, what caused you to go around the turn was the friction force. So that's not always apparent. So we're going to look in this section at what happens to what, or what is the action, what is the reaction. So if you're going to try to find what the forces are, try to find out, just ask yourself what interacts with what. So what is object A exerts a force on object B, that would be the action. Object B is is exerting a force back on object A, that would be the reaction. That's easier than said than done, though, sometimes. Sometimes the identity is not always obvious. Okay, for example, what is the action and reaction forces in the case of a falling boulder? Well, what is the force that's causing the boulder to go down? Okay, so what's happening is that the earth is pulling on the boulder. Well, that might be obvious, but what's the reaction force? If the earth is pulling on the boulder, then something else must be true. The boulder is pulling on the earth with exactly the same force that the earth is pulling on the boulder. Why doesn't the earth move? The earth is so much bigger than the boulder. If you have the same amount of force, remember, force and mass are related in F equals ma. So the bigger the mass, the more force required to accelerate it. So if you have a force big enough to move a boulder, it doesn't necessarily mean that it's big enough to move the earth. So there is a small amount of acceleration to the earth. If I jump up and the earth is pulling on me, I'm also pulling on the earth. There's a tiny, tiny bit, imperceptible rounding off, that would be an acceleration of the earth coming up to me. Now, if I weighed more than the earth, then the earth would fall to me. Okay, if I jumped up, the earth would fall up towards me because the earth is falling towards the heavier object, accelerating more. If you had two objects that were very close in mass, as one would move, the other one would obviously move. So here's a couple other ones. Tires pushing on the road road pushes on the tires. The earth pulls on the ball pushes on the earth. What about the rocket? They gave it away with the picture. The rocket pushes on the gas that's exerted. See, if you're in space, there's nothing to push against. Well, how does a rocket move? A rocket is burning fuel and gases are coming out of the tailpipe of the rocket. Well, the gases that are sitting there can be shoved against by the new gas that's coming out. So the rocket pushes the gas, and then the gas pushes the rocket forward. That's kind of a harder one. We know that the Earth pulls the moon. Does the moon also pull the Earth? Yes, that's how tides happen. The moon is pulling the Earth and it's sloshing the water back and forth, and that's why you have high tide and low tide. So, which one is pulling harder? Same amount of force that the Earth is pulling the moon and the moon's pulling the Earth, but the Earth is so much bigger that the force has more impact on the moon. And so the force of the Earth is actually pulling the moon around the Earth, and you've got an orbit. It's actually acting as a satellite. It's a natural satellite. So how do you identify action reactions of an interaction? Sometimes it's hard. You have to ask what is shoving on what, and then what is the reaction force to that original push or pull.